Alright, so I'm making this video just to show you guys how I troubleshoot electrical problems with, pretty much any make and model, ATV, older cars, anything with a cooling fan. It's going to be pretty much set up the same. So we've got a Grizzly 700 here. It's getting kind of older. It's like 13 now. It's going to be 14 years old. And the cooling fan quit working. So the first thing you're going to want to do is, with any fan, any system, make sure the fan's not stuck. Make sure there's no sticks in there. Make sure nothing got jammed in there and caused it to lock up. The bearings sometimes lock up and make it, not spin. So once you know that the fan is spinning, then you're going to want to find the relay. That's that's the main junction for all the electrical. This is not the relay. This is where it plugs in. This is the relay. So I had to buy a new one because I broke the old one. With cars, relays always just come right out. With off-road vehicles, a lot of times they're stuck in there, and I should have probably taken more time and crammed screwdrivers in there and oiled it, but I squeezed it with a pair of channel locks and ripped it out of there. So I had to buy a new one. But so you figure out which relay on your vehicle is for the fan, and that's like I said, that's your main junction for everything. Everything comes together there to make the fan run. So you're gonna want to figure out which wires do what, and the easiest way to do that is I look at the wires on the back here. So signal wires coming from the thermostat are always going to be just small little wires. They just pull the relay in. The relay doesn't require a whole lot of amperage to like make it work. So they're just going to be little scrawny wires. Your larger wires are always going to be for your motor, or whichever piece of the puzzle draws the most amperage. So now that we took a look here, we've got the smaller wires. Those are going to be coming from the thermostat. These two over here, larger ones, are going to be going to the fan. Well, one's going to be accessory power and one's going to be fan. So now we know we've got signal wires there on the right and we've got fan wires there on the left. And what I do, the next thing I do is, now that we know what's, basically what's what, we try to figure out if this fan is good, because even though it's spun over, it doesn't mean the fan's necessarily good. So this one was convenient. The wires are right here for the fan. So I look and we've got black and blue wires here. So I come over to the wires on the back of the relay and I see a blue one. So that means blue is your power, black is your ground, your common. So then what I do is I go ahead and just get a jumper wire, a piece of wire. And we're going to, since blue is your power, we're going to send it power. Make sure, you know what wire's what before you do this, because you could fry other things. But blue here is definitely power. So we've got the jumper wire shoved in the connector. And what we're going to do is go over here to the starter solenoid. And the fan comes on. Now, if the fan doesn't come on, that doesn't necessarily mean the fan is bad at this point. You're going to have to start checking the ground and make sure it has a good ground, because if the ground wire is corroded or broken in any way, it's not going to come on. But that's how I start testing the fan. So on this one, we know the fan's working. So we're going to move to the next step. Since the thermostat requires a lot more work to figure out if it's calling for fan or not, I'm just going to go to the accessories. So you've got this middle one here, that's your fan going, that's your wire going to the fan. So the other one over there has to be power. That's got to be, when the key's on, that should be 12 volts all the time. You should have power right from the accessories. So we're going to want to do, I'm trying to break this down in different loops. There's like 4 different loops here, or 4 different things that could be wrong. So I'm just showing you guys how I go about just troubleshooting. So we're going to stick the lead here, where is it? Right down into that guy. Gotta turn the key on, make sure accessory powers are on. Find yourself a good ground. Good ground. Come on. Oh, that fell out. Oh, stay in there. Okay, yeah. Go ahead and find a ground. Alright, so now we've got 12.5 volts. So we know the accessories are working. And we're going to move on to the next step. So we've got, fan comes on when we jumper it. We've got 12 volts coming from the accessories, from the key, to feed the fan power. Now we're down to the actual relay itself. We got to figure out if this is bad or if it's the thermostat. So we've got the fan, that's like one loop. We've got accessory power, that's another. And we've got thermostat, that's another, and then your relay. Those are the only things that could be wrong with this. So the way you test the thermostat here is what I already put all the plastic back on, but you're gonna wanna unplug the thermostat. It's gonna have a connector, some kind of Molex connector. You're gonna unplug that connector, and you're gonna just put a jumper wire. You're gonna make sure both wires are jumpered. Figure out what's what. You're gonna look at a yellow with a red stripe, and then we've got a brown back there. So figure out which one's what, and that's gonna be your power. The other one's gonna be your negative. That's gonna be your negative terminal. So confirm that the wires are the same color. That's your thermostat. You're gonna unplug it. This is not the thermostat. This is the wire going to the fan. I'm just trying to use this to as an example. You're gonna unplug the connector. You're gonna put a jumper wire from wire to wire. There's only gonna be 2 wires on your average system. You're gonna connect the 2 wires, and what that'll do is that'll send power up here. On this one, it's a yellow wire, so there should be 12 volts coming out of that with thermostat jumped. So with the thermostat jumped, you put a lead in each end here. One's gonna be negative, one's gonna be positive. You should have your 12 volts. If you have 12 volts, that means it's calling. So if you snap that relay in there, if you snap that relay back in there, and you got 12 volts there, that relay should pull in, and it should jump power from your accessories over to your fan, and your fan should be running. So if your fan isn't running, then odds are it's the relay shot. If your fan does run, then we know that something's going on with the thermostat loop. So what you're going to want to do is find the fuse. There's always going to be a fuse for everything. On this one, it's down that black box right there is a fuse box. There's going to be a fuse in there that says fan. And I don't know why they call it that, because it's not actually even for the fan. It does help make the fan run, but it doesn't actually power the fan. So I would call it thermostat fuse. But you find your fan fuse. It's a smaller fuse, not going to be a large giant fuse. It's only going to be just like a 10 amp fuse or so. You find that fuse, confirm that it is working. Power's coming out of that fuse box, going through the fuse, and then making its way over to the thermostat, which you basically already did that by jumping it. I'm going to correct myself here. When you jump it, you're confirming that fuse is working. If you jumper the thermostat, this thermostat's on the cylinder here, so that's why I keep pointing and looking over here. But when you jumper that, you're already confirming that fuse is working. So if you jumper it and it comes on, then all is well with basically everything except for the thermostat. Now, when it's jumpered, the thermostat is jumpered. If it runs, that means that your thermostat is more than likely shot. But that's basically it. I just wanted to show you guys how I troubleshoot basically any fan. Figure out what's accessory, what's fan, and what's your signal wires. And once you know what everything is doing, it's so easy to pick through and find the weak link. If you don't have accessory power, you're gonna figure out where that power is coming from. What fuse is it? look at the wiring. If the fuse is bad, I hate blown fuses because that means something went wrong and caused that fuse to pop. More than likely. I've changed fuses and things have worked for a long time and not had any more issues, but I'd say probably 19 out of 20 times, if a fuse is blown, something's wrong. Something caused that fuse to short out. So you got to determine what's going on. Use your amp clamp. Amp out the motor. Go right around the motor here, the motor wires, and get an amp draw. Look at the fuse. Is it a 20 amp fuse? Are you drawing 22 amps of power through a 20 amp fuse? If you are, then your motor is bad. Your motor is going bad. It's drawing way too many amps and it's popping the fuse. If it's not drawing a whole lot of amps, more than likely it's either going to be like a wire rubbed on the frame and shorted out and pop the fuse, or it could just be just a bad fuse. But figure out what's what and chase it down. Break it down into four different loops. I call them loops, 4 different systems. You've got your fan, make sure that part is working. Got accessories, make sure accessories are working. You've got thermostat, make sure the thermostat loop is working. And if everything checks out, it's your relay. If not everything checks out, then you figure out which one's not checking out and you chase after it until you figure it out. It's not that hard.